I hope you all copy the AND gate node and this one. Okay, so that is and NOT gate, NAND gate. Joining AND gate with the NOT gate, we call NAND gate. Okay, so NAND gate circuit diagram like this we can draw. Next one is NOR gate. NOR gate mean again OR gate plus another NOT gate. Mm, So how can we draw the NOR gate? NOR gate means we are drawing the OR gate, then in front of that there should be the NOT gate. OR gate, okay, little bit of curve shape, okay. Not the flat. And there is a pointer. Then there should be the, and some are drawing this one with the little bit of straightforward one. Like this way. The pointing should be also there. Then NOT gate. So assume this is X and here is 1 and is 2. Okay. And this is the L. So when we draw truth table S1, this one, I'll just take off this part. X, what is the X? Addition 1, 1, 1, 0. Then X bar mean L. L will be 1, 0, 0, 0. Okay. Shall we copy this one? And the output should be, X should be X equal S1 plus S2. Okay. L should be S1 plus S2 or gate S1 plus S2 over bar. Just look at there is an error in the school teacher guide. It should be plus and the over bar. Okay, not the dot. If you are referring the teacher's guide, there is an error. Yeah, that is wrong. Huh? I took the pen screen from the teacher guide. That is wrong. There should be the plus and over bar. Just look at this one. Okay, can you all copy down this one? Copy the note. The NOR gate is a digital gate that result the true if both input to the gate are false. If both are false, output will be on. Otherwise, result is false. NOR gate is a uh, NOR gate is the result of the negation. Negation means opposite of the what? Of the OR gate. Okay, copy this line. Okay, next one is XOR gate. So it was not there in the O level. This is for the A level one. So XOR gate pronounced as exclusive OR. Just look at exclusive OR gate. It is a digital logic gate that results true if and only if the input gates is true. If and only if input gate is true, otherwise output is false. That means if and only one input gate should be true. One should be true. That is very important. If and only one input is true, only one should be true. Only one should be true. That means if there are two truths, no. If there are two false also, no. අසමාන දෙන්නෙක් හිටියොත් ඔන්න එනවා. අන්න එහෙම ගත්තන හරි. Okay, bitwise XOR we have done earlier. If and only one input is true, only we will get the on. Otherwise, false. So it's easier to keep in mind if there are unequal things, then the output will be on. Okay, so the output we are writing, just look at addition and round circle around that addition symbol, plus sign and the round circle, plus and circle around that, we write the XOR symbol. And then if you have the S1 and S2 output, then we write S1 XOR S2. We pronounce it as also S1 XOR S2. Okay, this is the way how we pronounce S1 XOR S2. L equal X1 XOR S2. So symbol we write like that. Now you can copy 0 into 0 or 0 mean equal. 1 mean equal. If there are two equal, if there are equals, or if there are unequal things, that mean one only if and only one input is true, that mean output will be on. So this is the way how we draw it. Just draw two circles like that. Curve shape. Then like OR gate. Okay. So output is L. Input S1, S2. Shall we copy this one? Quickly copy down. So now we are going to look how to draw the XOR gate in different methods. Okay, so by looking the XOR output, we can assume that is consist of two inputs A or B, whatever two inputs, and just look at this one. S1 is input to AND gate. S2, not of the S2 is also input to the AND gate. So the output will be S1 dot S2 bar. Okay. Then this side we are getting the S1, and here I'll draw it. Okay. S1 is going inside. Here S2 bar is coming inside to this one. Then the output will be S1 dot S2 bar. Then here this side S1, then S1 bar, then this side S2, then S1 bar dot S2. Okay, then this side S1 dot S2 bar. Okay, those two, what should be there? Those should be added. So S1 dot S2 bar has to be added with S1 bar dot S2. Okay. So if these two are the input, S1, S2. So we are going to find out what is S1 bar, what is S2 bar, Then what is the output for S1, S2 bar, then S1 dot S2, S1 bar dot S2, and here S1 dot S2 bar, S1 dot S1 bar dot S2. මේ expression එකයි මේ මෙතන ලියලා තියෙන්නේ. These two we are writing like this way. ඉස්සෙල්ලා එක term එකක් ගත්තා, term by term, then we are finding the output. Okay? Then look at if the S1 is 0 and S2 is 0, opposite of S1 is 1, opposite of S2 is 1. So now what we need? The first term, S1 is 2 bar. So S1, S2 bar means S1 means 0, S2 bar means 1. 0 into 1, output will be 0. Same way, we are going to fill the rest. Then here S1 bar dot S2. S1 bar dot S2. That means this one, S1 bar dot S2. This part, S1 bar dot S2 means this one. That means this column. Okay. Then next we have S1 dot S2 bar and this column. That is this one. So finally, what should we do? We should add these two columns together. So adding these two columns together means I'm going to take the addition here. That means this is the addition part. Okay. So to find out this one by one, we have to take the S1 bar, S2 bar separately. Then only we are going to do the multiplication. Shall we try? So this one S1, if S1 S2 output 0 0 0 1 1 0 1 1. So out S1 opposite side, opposite complement of S1 bar. So that means S1 bar means opposite of this part. S2 bar means opposite of this one. Then S1 dot S2 bar we are going to find. Then S1 bar dot S2 we are going to find. Then going to add both together. Is this clear? Okay. So now in the top part, we have already drawn it. Draw the circuit and then draw the truth table quickly. If possible, without looking, you better draw. If not, if you have any issues, you can copy straight away. Okay, try this one. This circuit is very important. So normally for the exam also you will get this one. So instead of S1, S2, if you get AB, so you should know how to handle this type of question. Okay. So XOR can represent with the normal logic gate. Those are NOT gate, and OR gate. Okay. So straight away we can draw the XOR like using XOR gate, but without that, there's another way of implementing using two NOT gates and two AND gates and another OR gate. So normally AB is giving like question. So S1, S2, draw the truth table for it. Then take this bar and S1 bar and S2. Then find out the output S1 dot S2 bar plus then S1 bar dot S2. Then find the truth table output. Okay. So then next I'm going to move to the 3 input XOR. Assume there are 3 input. So S1 input, S2 input, and S3 input. So then S1 plus X1 XOR, then S2 XOR, S3 XOR. So there are 3 XORs. Actually, sorry, 3 input XOR. That means 2 XORs. Ne? S1 XOR S2, XOR S3. 2 XORs are working there. When we are using 3 input XOR. If there are 3 input XOR, then 2 XORs functionalities will be there. Look at the output 0, S1, S2, S3. There are three inputs. If there are three inputs, how to represent the possibilities? 2 to the power 3 mean 8 possibilities should be there for the truth table. 0, 0, 0, then 0, 0, 1, 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. We can represent with this like decimal numbers. Imagine first one is 0. 1, 2, 3, 4, 5, 6, 7. So 7 we represent it 1, 1, 1. Next 0 we represent 0, 0, 0. Number 1, 0, 0, 1. 0, 1, 0. If you keep in mind this pattern, then no issue. You can straightway fill the truth table. Okay, in possible inputs are represented with the decimal number. So if you consider, if you keep in this one in your mind, that means if there are three inputs, mean 2 to the power 3, 8 possibilities are there, starting from decimal 0. So first 3 are 0, then 0, 0, 1, 1 0, 1, 0, 3 means 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, last one 1, 1, 1. So first XOR in S1 dot S2. So if we get XOR for these two, if there are two equals, it will be off. If there are at least one, if and only one, that means we said earlier, what is the equation? Let's look at this. If and only one input is true. Okay, if and only one input is true. So when we considering S1 and S2, if and only one input is true, mean obviously these two are going to on. And here these two. If we highlight that point, if and only one input is true, here also if and only one input is true. So that position we will get four ones for the S1 dot S2. Then what is S3? So S3 is going to join with these two, S1 dot S2. That means that one, considering this and this, S1 XOR X2. Now we have the value. Then that is joining with the S3. So S1 is S1 XOR S2 XOR with S3. That means these two. Shall we check what are the if and only one input is true? So here, if and only one input is true, that means this position. If and only one input is true for this one, that is on. If and only one, no. If and only one, yes, this part is true. If and only one, if no, only this one. Okay. So these highlighted yellow ones are the true. Other things will be false. So compare S1, S2, and if the inputs are same, then the output will be 0. Otherwise, output will be 1. Compare the result S1, S2 with S3. If the values are same, the final output will be 0. Else, final output will be 1. Shall we copy the diagram and the truth table? Quickly try this one.